Good afternoon, everyone. My name is Rashmita, and I'm the event planner for Microsoft Reactor India. I welcome you all to the last episode from the AI Spark series. Let's welcome our speakers, Lee and Shreyan. But before we start the session, I would request you all to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section is open throughout, and we do encourage you all to participate. Our speakers will answer all your questions during the session, so please feel free to drop all your questions in the chat section. With this, let me bring in Lee and Shreyan into the stream, and thank you all once again for joining us. And of course, enjoy the session.
Thanks,
Over to you.
Rashmita. Thanks, Rashmita. Hi, everyone. Welcome to today's session. So this is actually the final session of AI Sparks, and I'm here again with Shreyan. So hi, Shreyan. We're really
Hi.
excited today, aren't we, to talk about agents. It's the year of agents. So give a bit of an intro about who you are, and then we can get started.
Yes. Thanks, Lee. Thanks. Yeah, I'm really excited for the agents, and that too when we are doing the session at the time of in the right span. And yes, hello everyone. My name is Shayan, and currently I'm a senior executive at KPMG India. In my free time, I do love to explore things. I like traveling, and I think you might have seen me from the past few sessions. So really excited for this one.
Excellent. So yes, so this is AI Sparks. We've been running this series from February 13th all the way through to today. So as we said, this is our final session. We would love to have those discussions continue in the Azure AI Foundry Discord, and we'll share some links to the Discord. And again, myself and Shreyan are in there. And of course, you can watch all the episodes on demand by just simply clicking on that QR code, and you've got access to all those. And today's session, of course, will be recorded and made available on demand. So today's session is all about, again, using AI Toolkit for Visual Studio Code, but we're going to specifically focus on agents and agentic frameworks and some of the new features that have been launched over the last week in terms of what we call the agent builder within AI Toolkit. So I'm Lee Stott, I'm a principal cloud advocate at Microsoft, and I run one of the AI core developer relations teams. Again, Shreyan is from KPMG, and we've been doing these episodes over the last few weeks to get you familiar with building with Microsoft tools, and specifically the Microsoft Azure AI Foundry, the Microsoft Azure AI Toolkit for Visual Studio Code, which is an extension, and of course, the easiest way to get access to models via the GitHub Marketplace models. So again, we're going to be covering those things again in more depth today, but we're going to focus about how to build agents and agentic frameworks. So this is an overview of some of the previous sessions. We started back in February on the 13th around AI Toolkit and where we were going with the product. So if you go back and look at some of those old videos, and it's not that old really, it's only a couple of weeks, things have moved on lots. We're in this change culture of, all these things changing, new technologies, new models every day. MCP wasn't even invented, and we might even talk a little bit about MCP today. And again, if you want to continue the discussion, please click on that QR code and it will go through to our Discord channel, where again, we're happy to take questions. There is a designated channel for AI Sparks. If you missed any of the episodes or you want to have more detailed conversation, please use that. Shreyan is Kamikaze on Discord, and I'm Lee Stott. So just tag us and you'll be able to see, and we'll continue the discussions. So the agenda for today, first of all, we're going to talk about understanding AI agents. What is an AI agent? How have AI agents sort of progressed technology-wise over, it's only the last year, so how have they progressed over the last year to where we are today? We talk about some of the AI agent use cases. So where are agents being used? How are they being used? We'll then talk about building agents with the AI Toolkit and the Agent Builder service, which is a brand new service. It's only been launched about a week. I think it's still in the preview. So if you're in the Visual Studio Code Insiders, if you go to the pre-release channel, you'll get to see all the latest bits as we're building and releasing. And again, we want your feedback. We're doing these episodes to get your feedback about the tooling. Does it work? What do you like? What do you not like? Then we'll look at exploring some of the agent framework services. So we're going to cover things like AutoGen. We're going to cover things like Semantic Kernel to talk about how do you start to build those agentic framework applications to orchestrate multiple agents. And of course, because this is new, we're going to talk about MCP, so the Model Context Protocol, and give you some ideas of how you can use MCP within Azure AI Toolkit, and also how to actually start to build your own servers and clients. So a packed agenda. And we've got the most demos of any session so far. And Shreyan, no more demos, but I love the demos. People love the demos. Again, we're going to be demoing using the AI Toolkit. So let's start with a bit of an understanding of agents. 2025 is definitely a year of agents. Been loads of buzz about agents, but agents have actually been around a long time. So if you look at where an agent is really about this semi-autonomous software entity. That's the key word, and it's semi-autonomous. You want to do something on the user's behalf. And what we're going to do is we're going to leverage language models, and they could be large language models, or they could be small language models. And we want them to perform a specific task and do it in a natural, interactive way. So be like a human in the way it responds. And the way we build agents is really around these three key pillars. It's about creating a plan. It's about receiving some context of that plan. So what does actually need to be completed and what are the steps? And then performing the action on that plan to undertake it and complete it. So that's the basis of how we think about agents. Again, I'm going to stress this semi-autonomous software. This is the big change from like a bot to where we are today with agents. It's that semi-autonomous, being able to do something with something on your behalf. So let's look a bit about history. So as I said, a year ago, we were all using chatbots, and basically a chatbot was very limited in terms of its knowledge. It didn't really know anything about anything else because it didn't have any models or large language models to talk to. And it was just really there to do a single task. It was able to perform a single action with a limited response. So lots of examples which people use were things like Q&A Maker, where you had an FAQ, you had a set of answers, and you had a set of questions, and you had a set of answers. And you wanted to build a bot that if somebody went to your website and they asked a question, it looked at the knowledge base and gave a response back. So again, it was very limited in its knowledge. It couldn't know anything about anything other than that FAQ. Again, it was very prescriptive in what it gave back because it only knew what the question was and the answer and potential answers. And again, it had limited scope of response because it was built as that single entity. So that was a single chatbot implementation. Again, there's nothing wrong with chatbots. Chatbots are still in operation, still being utilized, and they still have a purpose. So going back to that FAQ, if you've got a very simple FAQ and you want a very cheap solution, chatbot's a great solution. We then moved on to this world of generative AI. And this is really where we really came to two personas. So it was what we call generative AI applications without RAG, so without retrieval augmented generation. So this is where you had a response around some relevant data, but it was limited because it was only to the model. And again, if you're using a fine-tuned model, that model's data entity didn't know anything else. So, you could ask a question, get a response back from the model, and then, have that answer there. So the issue with that is, of course, because it doesn't really know the answers to everything, it could fabricate, it could make things up because it doesn't really know the answer. So again, if you're looking at those implementations, this is where, gosh, it feels like years ago, but it was only 9 months ago. People were talking about fabrications of models because models were hallucinating. They didn't know the answer. So that was before we had the ability of retrieval augmented generation. We then move into the retrieval augmented generation model. So this is where you get to provide much more valuable and relevant response. But again, it's limited to the data services that you provide your model. So you're having your base model, and then you're looking at external knowledge bases, and they could be things like Microsoft Fabric and databases. It could be SharePoint. It could be extensions like Bing, or even marketplace apps. We now have marketplace apps, and also different knowledge bases from like flat files. So again, you're bringing that data in, you're augmenting your model with that data, with that knowledge, you're grounding it. So again, you're doing your grounding, your relevance and your coherence on that model. And then you're asking a specific question. If it doesn't know the answer, It will actually, you know, not hallucinate to the same extent, but it will be much more accurate in giving a good, valid response back to the end user. So this is where we were with RAG. And again, this is where the majority of implementations sit today. And I think most of the people on the call, if you're doing any generative AI, you will definitely be either using fine-tuned models, if you can afford to build them, or you'll be using a RAG solution. Again, going back to some of our previous episodes, think of this as a funnel. We start with prompt engineering. It's the most cheapest, effective way of building good LLM output. So, you know, engineer your prompts. If you don't get a good response back, think about RAG. Think about augmenting the data. So there's now RAG, and there's also now something called CAG, so CAG. So think about how you reinforce the data with relevant information. If that doesn't work and you're still getting hallucinations of the models and not really good groundedness, relevance, and coherence, move on to fine-tuning. Of course, as the lower you go down in that funnel, fine-tuning's at the bottom, so at the very point of the V, it becomes more expensive. And it becomes very fixed. You know, if you fine-tune a model, that model is fine-tuned from today, from the day you publish that model. So anything from tomorrow, that model knows nothing about. So if you're fine-tuning a model, think about the lifespan of your model. RAG, you can just add another data source. Fine-tune, you've got to re-fine-tune the model with the new data source. Very expensive. So don't be using fine-tuning if you're in an industry that changes every week or every month. Think about it as that fixed solution. So then we move on to now the exciting thing of generative AI applications with agents. Okay, so what did we talk about? First of all, we talked about that ability to do something semi-autonomously. So this is the ability for a user to ask an agent. The agent will then look at the plan, it will look at the task, and it will look at the actions. So we want that agent to do that. So it might look at the plan and go, okay, these are the things that I need to do. So in this example, we're using a vacation booking. So I'm saying, I want a vacation day. I want to book 3 days. So the agent has to understand who I am, where do I work? You know, there might be country-specific laws or country-specific holidays. I want to book 3 days. And it also has to have links to that knowledge. So it has to understand the context of me, the context of where I am, the context of how many days leave I currently have, we've taken, how many are available, and how many public holidays. And it will need knowledge sources to do that. It might also need actions, so tooling or functions, to be able to call other services or data to be able to answer that question. And we want the agent to literally come back and say, yep, Lee, I booked you 3 holidays. You've actually booked this over a bank holiday. You've only need to take 1 day's leave. Perfect. So that's that semi-autonomous agent. So it's the ability for the agent to perform a task. It's the agent's ability to plan, create those actions, create the inputs, and create the response back to the user. And also have that ability to use knowledge bases and understand the business processing, tools, legislation, and requirements around me in my current role or position. So this is like a massive change. And again, this is like really new, to be honest. This is, 6 months, 5 months old, and it's changing continually. And we're getting better at doing this as we provide better models for those agents to consume. So now we have things like reasoning models, and we have, bigger context windows. So again, this is going to get better and better, and that agent will become more and more responsive and more semi-automotive as we move through the technology roadmap. So let's talk about the next stage, which is all around what we call these agentic design patterns. So what we're doing here is taking it from that single agent to a multi-agent solution. So again, if we take that example of, the vacation system, as I said before, it needs to know those things about me, my organization, the data within the organization, the policies within the organization. So I might want to construct this using multiple agents because I'm asking lots of tasks, and that agent's going to have to go off and plan all this. Whereas if you use a multi-agent design, each agent becomes a specialist in that area. So in this example, I've got a booking agent. So the booking agent is basically going to handle the booking of that calendar invite, the processing it to the back-end system and confirming it to me as a user that, my holidays have been booked. I've got a data agent who's going to handle that data integration layer. So it's going to look at, the math, how many days do I have? How many days have I taken? How many days are public holidays? And I've got the HR agent who is the specialist to HR. So it understands those things like, what are public holidays? What country do I live in? What are my leave entitlements? And again, that is then going to go away to those knowledge sources. Each agent might have its own knowledge source. Each agent might be looking at the same knowledge sources, but having that specific persona and responsibility to then ask me or answer me the question. So again, each agent is in isolation. So number one, we're talking again about security boundaries. If something gets compromised, it's only one agent within the whole system. Each agent is only be able to perform specific tasks. It's like, responsibility and reducing the footprint of that exposure point, because that agent is only doing that one thing. Agents aren't overloaded, so they're not having to create this crazy plan and perform the actions and the tasks. And then again, agents have specific tools that they can then utilize. So again, going back to that security and boundaries, our HR agent will only have access to our internal HR systems. None of the other agents will know about that. We don't want the other agents to have permissions to that data in case, it gets compromised, etc. So again, this is where we're going now with this multi-agent design. So what we're going to be talking about today is how do we orchestrate and how do we build those multi-agent implementations? So let's first of all look at some of the use cases for agents. And again, we're going to look at this from an industry perspective to give people some grounding in terms of what and where agents can be used. So we've got lots of different examples here, from travel booking and expenses management, employee onboarding, personalized customer support, and data analytics and reporting. So let's just look at the personalized and customer support, because I think we've all experienced this. We've all experienced a chat bot with a customer call center today. And I think we've all got frustrated with it. And now if we think about that from an agent design, we can start to think about, how can a single agent or a multi-agent be used for this? So we've got things like diagnostic issues by referencing history and product manuals. So again, if we take this into an example, we log into a customer support site and we've purchased something from them. They understand what we've purchased. They understand when we had it delivered. They understand our previous purchases. They understand any diagnostic information about that item. So has there been a recall? Is there a software update? Is there any problems with that? So again, think about this from an agent perspective. We could have that as a single agent, customer support agent. Hi, welcome to the service. We understand you've made these purchases. Do you have an issue? These are the current recalls. These are the current updates. So it's providing that tailored solution. It can escalate through those automated workflows because it's got access to the back-end systems and that knowledge. So it understands like, oh, if there is a fault, I'd know how to raise a support ticket and then know how to do a follow-up, and then can give you a shipping label. You can then return the item. I can update the CRM. I can do the recording. I know that when you posted that posted the item, there's a tracking label on it. I get the tracking reference number and I can give you a refund automated. So straight away, we've gone into this agentic framework design by building down those different tasks. It's that plan. What is the plan? So when you're thinking about these agent processes, you should be thinking about, how do I design that plan? What does the agent need to do? What are the tasks? What's the data associated to each of those tasks? Then ask the question, should this be a single agent doing all this? Or can I compartmentalize some of these activities and tasks to be done by specific agents? And then can I orchestrate these agents to talk together? So that's what we're going to be doing today, is looking at these scenarios and then building on these scenarios with real solutions. So let's talk about building agents. Key thing when we're considering building agents is, number one, the models to use. So if you look at some of the previous things that we've talked about, it's that knowledge. Does the model today have the right knowledge in it? Do we need to RAG it? Do we need to fine tune it? Do we do evaluations and benchmarks on the models? That's like task one. Which is the best model to utilize? Because that's going to be our knowledge for the agent. Does it have the right context? We're then going to have the agent doing a number of actions. So we're going to give the agent access to the tools that it needs to complete the task. So again, does it have access to the data? Does it need to be a multi-agent solution? Security. we need to ensure that agents only have access to the data and services they need. Now, this is so key. Going back to that plan, we don't want to start to compromise systems, because we can start to do things like jailbreaking or injections based on the agents to different systems. So security boundaries are really key. And then we want to evaluate the agent. We want, so going back to the discussions we had about models, evaluation is an iterative process in this stage. So it's like build, design, evaluate, build, design, evaluate, build, design, evaluate, because you always want to ensure that the agents are completing the task correctly. Are they doing it the most effectively? And again, most effectively, when we talk about agent design, is cost. How many tokens are being utilized? Are we using the right model? Could we use a cheaper model? Is the context window too big? So there's lots of things that we need to think about from that evaluation perspective to ensure we're using the right model. So if we break this down into each of the sections, so in terms of knowledge, we've got our data. Data is gold. I should have worn my data is gold or data is my DNA t-shirt today, because garbage in equals garbage out. Okay. So knowledge is based on the data that you have. So if you have conflicting information in your data services, what will the agent do? The agent will be confused. It will like, which is the best answer? Because there's two different answers here. So make sure you have the data quality in place. There's things like external connectors, so things like Bing search, or you can use APIs, or you can use MPC, and we'll talk about this later, to be able to call other services to validate or to get additional resources. Again, where's that data sit? Is it your own data? Is it public data? Is it a mixture of both? Or is it just simply flat files? So you're going off and looking at a SharePoint site and bringing back everything. So knowledge is like step one. Make sure your knowledge is in place. Then you need to think about those actions. So what are the actions agents need to undertake? Is it going to be things like using Azure Logic apps or function apps? Is it going to be using open API tools? Is it going to be using APIs that you customly built because you can call them? Then we've got the security. So we've got things like content filtering. How are you going to protect your models from jailbreaking? How are you going to protect them from like releasing copyrighted information? We've got the security around our storage. We want those to be, and then we've also got the user authentication to make sure only the right people can access those agents. If you're building an internal agent, you don't want your customers using your internal agent. And then we've got those evaluations. So we've got the tracing and monitoring, the model flexibility and choice. So again, this really comes down to one of the massive benefits of what we call the Azure Inference API and SDK, is that today we currently have GPT 3.5. GPT 3.5 will become end of life in early June. So if you're using 3.5, it will be decommissioned in early June. I think it's the 5th of June off the top of my head. There is a date when you go to the site. If you need to change your model, all you need to do is change that model name. So you change where it says GPT 3.5 to GPT 4.0 mini. No other changes are required in your code. So this is about that model flexibility. So again, which model should you use? You should be evaluating the models, benchmarking the models. If you need to change the model, go in, change the model. Very, very simple. It's one line. It's literally 20 characters. It's the name of the model that needs to be changed. So again, think about that flexibility design. So let's explore the Agentic AI frameworks. So within Microsoft, we really have these three key pillars. We have our Azure AI Foundry and what we call the Azure AI Agent Service within AI Foundry. This has really been designed as a managed agent service for producing a single agent. So if you want to produce a single agent solution, you build this, you use this tool to do it. And you can either do it in code first, or you can do it in a UI approach. So I'm start with Azure Agent Services. If you're looking at a multi-agent orchestration-based system, Microsoft has two solutions. We have AutoGen, which is based out of Microsoft Research. So this is really like state-of-the-art, cutting-edge, really impressive stuff. And again, it supports mainly Python. So, that's one of the key decision makers about, your language choice. And then we have Semantic Kernel, which is our production-ready and stable SDK, and that's available in Python, Java, .NET, etc. So, these are the three different frameworks, and we've talked about each of these, and we're going to focus today on AutoGen and on Semantic Kernel. And Rohit's just asked a really good question saying, could you please elaborate and provide examples and frameworks for evaluation? I'm looking for real world examples that you can share. So again, in terms of evaluation, there's lots of different metrics available. So there's like Blue, Glue for data integrity. There's also evaluations of like performance of the agent itself. So validating and benchmarking your agent. And again, Rohit, when Rashayan's doing some of the demos, I'll stick some links in the chat. But again, you need to build those evaluation processes. And under AI Foundry, we have a tool called observability, so evaluations. There's now tooling available for red teaming. So you can do red teaming, which is security validations. And you can also do evaluations of the data quality. So again, lots of resources around how you can best do these processes. Most importantly, this all fits into what we call Gen AI Ops. You'll see it sometimes called LLM Ops or Gen AI Ops. And it's the DevOps process around building these solutions. So again, think about how you as a developer are not just going to build this, deploy it. It's like, how do you build it, maintain it, evaluate it, iterate on it, refine it, republish it. So when we look at using the agent service, the agent has access to large language models. Again, that could be any model. We don't limit you to the model. This is about you doing that evaluation of what is your business context, what's the best model. We provide you access to those tools. And then the way the agents run is we have this thing called threads and runs. So threads and runs are how the agents actually talk and integrate with your solution. Again, we've got some great examples as we talk through the demos of how this actually works. And then we've got the run where you actually perform the tasks and give the response back to the user. So what we're going to do is we're going to go into a demo from Shreyan around using Semantic Kernel. So Shreyan, do you want to give us a demo of Semantic Kernel with AI Toolkit around this solution?
Yeah, sure. I think we studied all these things right now. So what Lee said is absolutely right, because we are in this era of agents where things are getting semi-autonomous, and there's a lot of discussion. There's a lot of use to that as well, which we'll see in the demo now. So to begin with, let's just kind of go through what the scenario is like. So what I will do here is I will use semantic kernel, right? The LLM that Lee just mentioned, right? The initial part is your LLM. So for the LLM, I'll be using AI Toolkit, the model that is available on AI Toolkit, which let's also give it a try with the offline model along with the GitHub models as well. Right. So what I'll do here is I want to design a travel booking agent for me. Right. So let's say I want to travel to here. I'm saying I would like to go to New York on 25th April. Right. So just with this, I want my tickets to be booked. Right. So with just one statement, can you see what are the hard tasks that I have? Like I have to go to a site, navigate, sit, check for the optimal timelines, and then book. I want to automate all this, right? So what I do is I kind of use a agent here, right? So to begin with, I've imported a couple of libraries. There's some Python coding to it. Just hold on, bear with me for some time. There is also content where I will talk about low coding platforms as well in a while. Right, so I'm just importing a couple of libraries. Again, the framework that I'll be using here is what just Lee spoke about, and that is Semantic Kernel, right? Semantic Kernel is an open source framework provided by Microsoft again, right? So it has a lot of connectors, it has a lot of contents, it has something called as kernel. You can design your plugins, right? So just to summarize, what we will be looking at here is mainly two parts. One is the memory. How do I give memory to the model? And second is how do I give tools to the models? Now, tools here I'll be naming them as plugins according to the nomenclature of semantic kernel. So whenever I say plugin, just relate it to like a tool that I'm designing, right? So the first part is to give a memory to the model. So that's what I've done here. I've given a chat history. Then the next part, okay, I'll just run the cells parallelly. So again, to run, I'm using a Jupyter notebook here. For those of you who are new to coding, so you can go to Visual Studio Code, install Python on your machine, and then you can just save your file as .ipynb, and you'll get a Jupyter notebook like I'm using here. And again, I'm using a virtual environment here, as you can see, and I'm using Python 3.11.9, right? So this is executed. I'm going cell by cell. So let's execute this. And now it's time to define the plugin, that is the tool, right? So I'm defining a class, book travel plugin. You can define anything that you want. It's basically a sample travel booking thing for me, right? So I'll define the tool here, and I've named it as book flight, and a small description what it does: book travel to given location and date. And here, right now what I'm doing is I've hard coded it, but this is, maybe you guys can give it a try. You can use any API here as well, right? You can integrate your API, which will actually let you to book a ticket, right? So you can try doing a dummy system here. For now, to just keep it simple, I've just given something here, and I've created my first plugin here. And now it's time to create the engine, the main orchestrator, who will kind of decide what to call, how to do, and how to stitch things together. Now that here is called a kernel, right? So to initialize a kernel, again, it is very simple. I'm doing it here. Kernel is equal to, and I'm calling that. Then I'm adding my plugin, right? So this particular thing, I'm kind of stitching the things together here, right? So I created a kernel, and now I'm adding the plugin that I just created, that is book travel plugin, right? So you can create multiple plugins, which I'll come to later. And after this, it's time to define the client. Now, usually there are multiple clients that you can choose from, right? So what I will be doing here is I'll be majorly focusing on AI Toolkit. Okay. So what I do here, I use async OpenAI. Now, many of you might ask why, if it's a POC or it's a very basic application, why am I using async? The reason is there are multiple calls that happen here in the backend, right? So there might be a chance that without async, it might not work smoothly. So that is why it is highly recommended whenever you use anything, especially with agents, it's better to go with async methods, right? So async is basically kind of used for basically for load handling, but here to handle all the calls, right? And after that, I have one here. You can either use a GitHub model, so, or you can use a local model. Now, those of you are new here, and yeah, so those of you are new here and this is your first time, so this is the model I'll be using from AI Toolkit, right? So let me just give a small intro to that. So you can go to extensions here and download something called as AI Toolkit, right? So once it is downloaded, you can see an extension here, and here you can see the playground. And here there is catalog in which you have models and tutorials. Then there are my models that I have downloaded or I have access to. Again, if you want to go through this, then there are sessions wherein we have covered this in depth. So now I go to playground, and I have already downloaded a 5 model form, right? So let me just choose it from here, 5.4, and I'm just waiting for the model to load. So it is again loading from my machine. It's not going to any kind of online place. It is a downloaded model, and that's what I'll be using today. In the meanwhile, you can also do a port forwarding. So now, if you can open a terminal and go to ports, you can just click on add a port, and then you can give in a number here. Usually what I do is I prefer 5272. It is completely up to you which port do you want to choose, right? So once you're done doing that, you'll have a port here, which is ready to use. Now, this is the setup that you have to do before executing the code that I have going to demonstrate now, right? So again, going back till the model loads, I'll also showcase you how to do it with GitHub models. Now I've created an env file here wherein I have uh, kept my GitHub token, right? And then I have defined the API key and base URL. So two things you'll have to do. First is you have to define the API key and the base URL. Now, for GitHub, you anyway have an API key, that is your access token, what we call as PATs. But what about AI Toolkit, right? Since AI Toolkit is a local infra, it's running on your local infra, there is no API key as such. So you can pass anything dummy. So as you can see here, I have passed AI Toolkit. And then you need to pass the base URL. That is nothing but localhost and the port number that I forwarded it to, and the v1 root, right? This is the endpoint that you hit to get anything out of the AI Toolkit's port forwarding. And now after that, what I will do is I'll create an AI service for the OpenAI chat completion, right? So you can define the model. If you're going with a GitHub model, then you can choose any of that. Just make sure you give the right model name. In case you are using a on-prem model from AI Toolkit, there's a small step you'll have to do. You'll have to head back here, and since I'm using a ONNX that is running on my local, so I'll come here. So this is the 5.4 model. Right click on it and copy the model name. Right. So once you have the model name ready, you can go back and you can paste it here. Right. And async client is this client that I'm referring to. You can execute it and it'll be done. Yeah. So it's successfully executed. Now I'm again creating here the request settings where I'm just passing all the parameters, and then finally I have a function wherein I ask the things. So again, since it will take a while, since it's my offline model, it will take a while to do things. So I've just kept the cell running here, right? So it looks like there might be a typo. This is something about hallucinations. You can definitely control it, but at the end you can see what is it that is being called here, right? So 25th April, and it has booked my ticket. So this is a basic demo of how you can do your semantic kernel using the AI toolkit. Lee, anything to add on?
No, but I think you've got a Teams call.
Yeah, I'm getting a call.
I can hear Teams ringing in the background. It's like,
Yes.
ring, 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 ring.
Yes, yes.
Cool. No, it's a really good overview and some great questions. So, like, you've got Jad who's asked, can you orchestrate agents built with Azure Agent Service using orchestration tools? Yes, the answer is yes. You can orchestrate them using Semantic Kernel, and I put a link in the chat to a dedicated blog on that. Again, there's lots of really great questions. Rohit's asked a question about evaluations. And again, this is what we want. We want these conversations. It's a bit terrible to write responses back in YouTube comments. So apologies, like I've got multiple streams of comments. If you do have like really in-depth questions, please do use the Discord, because we've got great samples on here around, how to get started. Now I'll just ask a question. I get this sample happens to use SK. Is it possible to use local AI toolkit approach from other frameworks like AutoGen? Niall, hold on. We're coming to it. So yes, you can. And we've got some demos to showcase that as well. Again, really just what we wanted to show here was like how you approach SK development today using like VS Code, and then how you can actually import that into the AI toolkit and then get access to those local models using Onyx, or if you want to use Olama as a model provider, or if you want to use GitHub models. That's one of the massive benefits of where we are in terms of being able to use AI Toolkit, because it wraps all the different AI services together and provides you a nice UI, UX directly with VS Code. So you're not leaving VS Code, and you've got access to that extensions and other services. And again, the new agent builder functionality. So if we just go back to the deck, I just want to talk through some of the scenarios that we're going to show in the next demos, just because it just makes it slightly easier to interpret and explain. So yeah, brilliant. So, okay, so what we're going to cover first of all is a process called function calling. So we explained it earlier on that, function calling is the ability for the agent to go out, grab something, and bring a response back. So if you think of function calling today, it's quite insular. It's like we want to do a single thing. We want to go out and call something. So in this scenario, we're going to create an agent, and the agent's going to be a flight booking agent. It's going to book travel. So it's a flight booking agent, and the instructions that we're going to give it as a user is to book me some travel on a given date to a given location. We're going to use some models because, again, we're using AI Toolkit to do this. So we've got that flexibility of model choice. We can use Microsoft models, we can use OpenAI models, Meta models, Mistral models, Cohere models, all the models available. We could also call other data sources. We could call that, that RAG ability. So using Azure Search, local files, etc. And we can do these tools, so these functions. So we have lots of different tooling available. We've got things like file search, we've got code interpreters, we've got function calling, we've got extensions like Bing Search, Microsoft Fabric, Microsoft SharePoint, and then we've got our logic apps, APIs, and functions that we can call. We're then going to create a thread. So going back to what I was saying before about how agents operate and work, what we do is with the thread is this is where we actually do the user message. So it's like, I would like to go on a trip on this date to this location. So this is our thread of our message. We're then going to run the agent function calling. So the agent's going to take that message, build a plan, figure out what it's got to do. And it runs a function calling. So it's going to go off and it says, I need to go and look at some of the database. I'm going to look at a database of knowledge because I've got that data available. And then I'm going to bring back a response back to the end user to say, your flights to New York have been successfully booked, because I'm going to understand this entity of how to do this. We're then going to check the run status, and then we're going to run the agent interpreter. So we're going to say, what do we want to do next? Is we actually want an email to be sent. We want an email to go to the user to say, yeah, we're going to create you an email, and then give you a response back in an email. So what we're going to do then is run a code interpreter tool that goes off and grabs our email service. So it grabs an SMP service, creates the email, wraps the email, sends the email back to the user. So then the user gets displayed an email confirmation has been sent. You check your email and you've got a lovely formatted email that says, yeah, your flight to New York on January 31st, 2026 has now been done. So that's like a great example of how function calling works using these toolings and agents to do a single task. It's like, I want it to do a single thing. The next demo, so this is going to be demo 1 that Shreyan shows. The demo after this is we're going to talk about agentic patterns and agentic patterns using Semantic Kernel. So that was me going back. So again, just to talk you through this scenario, same process, so it's the same 4 steps, but in this one, we want to do a day trip. So the question I'm going to give is, I want to book a day trip. The instructions are, book travel given location, date, and come back with some suggestions of what I want that agent to do. So this is like a lot more open-ended. It's like, where do you want to go? What do you want to do? What do you want to see? What's your interests, etc. So it's going to use a model. It's going to use that data again, because it wants to know a lot more about what we want to try to achieve. We're going to create a thread. And the thread is, I would like to book or make a day trip. We're then going to do that function calling to go off to our data. But then the agent is actually going to do all these different planning tasks. And it might use multiple different agents to bring back that full day trip itinerary. It's then going to run the status and it's going to run the coding steps. So it's the same process, but we're also going to give it this thing where we don't like that idea. We don't want to go there. Can you suggest something different? So again, it's going to go away and run those code interpreter tools, do the email again, and send us back a new confirmation of a new idea and give us that response back with an alternative suggestion. So we're building on this now with a multi-agent agentic pattern. So this is what we want to really show, is the difference between like just doing a function call, single implementation, to doing that agentic design where we're looking at the solution. So Shreyan, back over to you. So I think the first demo we're going to do is with AutoGen Studio, and then we're going to do a demo with Semantic Kernel.
Right. So let's go through all the scenarios that Lee was just talking about. So to begin
do you want to
with,
just zoom in slightly? Sorry, just
sure.
I'm old and I'm going blind, so that's perfect. I'm sure is that better for everyone? Just just say yes, and that'll be great. Cool.
Okay. So to begin with, the first scenario that Lee mentioned about the travel agent, right? So I want to book a flight. I think we just went through this, but to reiterate, so we'll create one plugin here, and then we'll add it to our kernel. We'll define our client, what client are we using. So let's now try using with the GitHub models. The same thing can be done with your AI Toolkit models as well. Right, so here I have again created that, and I've created a final I would say the last function that I'll be calling, which actually invokes the model, calls all the process, and I'm just running that. Now let's make things a little more interesting, right? So I created one tool here. How about creating multiple tools to see what all tools are being called on the runtime? So now let's also convert this into an application of, that I can visually see than just code running all over, my terminal. So what I will do, I'll again have the same plugin. I've created my plugin here and I've added it to my kernel, and I've used this one. You can also use, in the interest of time, I'm using GitHub, but if you really want to try it out, all you have to do is the setup that I showed you before. So go to toolkit, load the model in the playground, and copy the model name, and then just do a port forwarding, and you're good to go. So after that, I'm just giving the chat history, I'm creating the website here, and I'm executing it, right? So this is again with single. So now what I want to do is I want to add something around time, and I also want to add something around weather, right? So since I created one plugin, creating multiple plugins is not a problem. So let's try that out as well. uh, the first plugin that we had was just the book travel. How do I book travel? Now I also want this travel agent to tell me what is the weather. So imagine your travel agent is in US and he knows everything about that place, right? How is the weather going to be? What is the weather now and how it might change? So he'll help you with the right, a weather plan and your whole travel plan. So also I've created the time. This is just for the agent to know what time it is and how to relate. And here I have created another plugin for weather. So this basically provides me weather information. And I have created a news. So what if there is some disturbance because there is some news that is happening there? So this particular tool will also fetch that particular news that is happening in the uh, area or the region where you're traveling to. So again, I initialize my kernel and I'm just adding all these plugins together, right? So now again, I'm using my client just like before and I'm good to go. So let's now launch this application, right? So I have it ready here. So as you can see, I've done multiple chats. So I can ask here, I would like to book a flight to Paris on April 24, that is today. And Uh, what's the weather there on that day? I mean, that is today, right? So let's just submit it and see. So as I initially started with semantic kernel, I told you 2 to 3 different parts, right? So the first part is how do you give it a memory so that it is not uh, going haywire of what you're asking or what was the previous query, right? So to do that, I've also given the memory that you can see here in the chat history section and all the chats that I've done. And here you go. Before I could complete my explanation, I have an answer here. I've already provided the information because it was there in the memory, right? Paris, here it is again. Your flight to Paris has been successfully booked, and I'm flying to Paris. The weather forecast for that day indicates it will be sunny with a high of 25 degrees Celsius, right? And you can see the tools that Lee was mentioning, get weather, and all those tools, they are also being called on the runtime, right? So this is how you can kind of demonstrate how basic tool calling works. Now, next, to make things a little more interesting, let's build a itinerary agent for me, right? So let's say now I'm going to Paris and I want to plan my itinerary. So right, I'll build an agent for that. That's the next scenario that Lee mentioned in the slides, right? So I'm having here, right? I've imported all the libraries and I'm just giving random destinations here, right? So this can be your database. You can connect it to live database as we mentioned in the explanations, right? So you can have a real-time Bing connector, you can have a real-time database connector or anything of that sort wherever your repository is. Let's say you're running your own travel agency and you have certain destinations that you serve, right? So you can put that database and directly just connect it here, right? So again, I'm creating a function here, the kernel function, just like I'm not going in depth because this is what we have done before as well. I'm doing it again. So I'm just skipping that part. And this is just to load my env file that I've created here. And I'm just giving GPT-4 mini. And here I'm just giving it a system message that how should it behave, right? So you're a helpful AI agent. Again, it is the agent now, and that can help me plan vacations for customers at random destinations. And the name, you can just give it a name. What name should the agent be like? And you can see this is one step that is different from before. In the earlier case, it was just tools that were being called. But if you see here right now, it is not just the tools that are being called. Instead, it is an agent. It's agent in itself. So it can do semi-autonomous tasks that Lee mentioned at the very beginning of this session all by itself, right? So I can do that here and I'm giving user input. So first I'll ask it to plan me a day's trip, and then I somehow do not like what it is saying, right? I want it to replan it for me. So I say, I don't like that destination. Please plan another vacation for me. Again, these are all the codes that I've written just for formatting and things. And here you go. Once I execute this block, what comes out for me was the first question: plan me a day trip. So that is going to the agent, and travel agent tells me that great choice. How about a trip to Berlin, Germany? Here's a suggested itinerary for you. Morning, you can have this. Midday, you can do this. Lunch, you can have this. Afternoon, and it gave me a very beautiful itinerary, I would say. I am a very keen explorer, and I love to go on trips. So I think this is really helpful for me, and I can totally relate, than sitting and just typing on the internet and then sitting for hours together scrolling, shortlisting things. It is giving me out everything in one go. And then I said, okay, I do not still like it, just make me plan me another vacation. Then what it does is Rio de Janeiro, Brazil, right? Here's a suggested itinerary again for this thing. So on and so forth. I've just given here two things, but you can have multiple tasks that you want to do, right? So all one after the other, it will be done. So this is how you can build agents using semantic kernel. Lee, anything to add on before we move on to AutoGen?
No, so I think that's a great example of what we just went through in terms of that flow, adding the agentic framework solution, making the agent autonomously. And again, a lovely itinerary that's going to either be emailed or given back to the user in the app, which they can then take forward with them. So yeah, let's look at how you could do this in AutoGen Studio then.
Right. So now the next part, I think one of you even asked about AutoGen. So there is a coding way. Too much of code for the day, right? Let's just skip that for now. And I will show you how to do it with AI Toolkit. How do you link AI Toolkit to AutoGen? And let's see how do we build agents around that. So now I have launched my AutoGen Studio. It's very simple to launch. You have to just do a pip install AutoGen Studio. And as Lee mentioned, AutoGen Studio is majorly for Python, so you will have to have a good, I would say, hold on it. So I'm just doing that, and I'm launching it with this command, AutoGen UI, and I'm giving a port. You can choose any port. Feel free to choose any port. Now, one more prerequisite is, since we are using AI Toolkit, I want my model to be running as a server. So again, I come back to AI Toolkit, and I'm choosing the 5.4 for now, or you can choose any. You can choose 5.3 Vision, or there's DeepSeek as well. There are a lot of models you can go through in the catalog. So let me choose 5.3 Vision for now. Okay, and I'm just doing the port forwarding as I mentioned earlier. This is a very important step if you want to integrate this with AutoGen, right? So once you're sure that this is working, let's now move on to the AutoGen Studio. So once you give that command that I was just showcasing, you'll have this beautiful Studio UI up and running for you. So we can go to gallery here, and you can see Teams. This is a recent version of AutoGen Studio. In the earlier versions of this, there was something called as workflows, and the UI was completely different, but now it is slightly advanced and has much more features, right? So I'll go to models in the gallery, and I can just click on add a model. So now I've already added, so I won't add it, but I'll just showcase here. So you can give a model name, you can give a description of the model, you can give again the configuration, what is the deployment name of the model. So what comes here is what you copied from here, right? So I come to AI Toolkit, I copy this model name, and that model name goes here, right? It's not just 5.3 Vision. Why am I stressing on copying is that it is not just 5.3 Vision. There is a lot more to it. And if you do not provide this, your AI toolkit will fail to serve that model to you, right? So be very careful when you give this model name. And then API key, as I said, it's AI toolkit, so there's nothing to do. It's you can just give any random string. You can even give XYZ. That should work pretty fine, right? Base URL, again, where will you find the base URL? That is the same URL that I was showing you before. That is localhost, right? And the port that I forwarded it to, that is 5272 and then /v1, right? Make a note of this URL because this is the only URL that will support for you to access the AI toolkit, right? And then temperature, all the other things can be given. Now, if you do not want to give it this way, there is also a form here, right? So you can go to this JSON editor here, and you can see I've given all the parameters, right? You can say, is it true for vision, function calling, is it true or false? Actually, it's false here, and then the base URL, right? So once it is done, let me just change this to false and then test. So right now I'm showing you how to, oh, sorry, I closed it, my bad. Yeah, I'm just testing the model that I'm just added here, right? And as you can see, it's successful. So it's on my side now, and you can see that model component loaded successfully. It passed a query for testing what is 2 plus 2, give me only the answer, and you can see the finish is in stop, content is this, and so on and so forth. Similarly, you can also add a deep seek model, which will give you slightly better reasoning. I've already done that. It's the same process again through AI Toolkit. Again, I'm doing it here. I'm testing it. Make sure while you're testing it, your AI toolkit is serving the model on that particular endpoint. If you do not do that, then it is failed here, right? So I have not, let's just see if it's able to do that. Since it's deep seek, it will slightly take a longer time. I can show you even the task manager as well here, where you can see the inference engine running. As you can see here, the inference engine, it's using 100%. Can you see this inference service agent? This basically shows that actually it is connecting to my AI toolkit endpoint, right? It's taking a while to test. Let's just give it 2 more minutes and then we'll go to the next thing. Also, if you want this JSON, I will definitely upload it in the repository as well. You can find all the codes and all the materials I use here in the AI Toolkit samples repository. Okay, I have to load the model here. And as you can see, I did not load the model and hence that failed here, right? So if I load it and if I test, it should give you the successful output here. Okay, it's taking some time. In the interest of time, I'll just move on to the next part quickly. And then once you have the models imported, I have 2 models imported here. Next thing is to create agents, right? So I can create an agent here. I've created one 5-3 vision agent. And what does the agent do? I'm just giving the name, and you can configure the model here. Again, whatever you just configured, you can use it here. I'm using 5-3 vision, and I'm just going, you can add tools. If you want, you can add tool here. You can create your own functions in Python and your agents are ready. Now the workflows, right? So agentic workflows, what we call of AutoGen Studio, that can be done here visually as well. As you can see, I've not done any much coding here so far, right? So I can just create a new team. I can drag and drop what I want, right? So I can use this 5-3 vision agent. Then let's say for tools, I can use a calculator tool here, right? I can drag and drop it, and then whatever other tools you want, and you can just save and execute this workflow. It will run as smooth as your simple code. If you don't want this, you also have a JSON here. So this is how you connect your models from AI Toolkit to AutoGen. I think one of you actually asked this question. I think I hope this answers that point. Lee, anything to add on to this?
No, again, a great overview. So, just to stress, AutoGen is like cutting edge, rapidly changing. It's really like leading the edge of where we're going with agentic frameworks. It's a research project. They are producing lots of research reports and content. So again, if you're really interested in like keeping abreast of what's going on, definitely look at the AutoGen framework. Semantic Kernel, a lot more robust, lots more development languages. Lots more support, of course. So, they've got dedicated support channels in the Discord channel. They run product group meetings and AMAs. So again, lots of different activities going on, but great demos. So let's now go back to the slides and talk about the new thing on the street, Model Context Protocol. Brilliant. So yeah, so Model Context Protocol is about 3 weeks old. So it's an actual, so the key thing with MCP is an industrial standard. So this is like TCP. So it's a protocol. It's an open protocol that's been established between between Microsoft and a few other leading partners out there in the industry fields. And what we're trying to really do is establish a protocol for the seamless integration between LLM applications, and the ability to use tools, data, and sources. So if we sort of look at the landscape today, we've got APIs. So everybody knows what an API is. It's a standard application of how to interact with the backend, whether it's a server, database, service. You call an API with a REST endpoint and you get the data. There's LSP, which is really standardized how IDEs interact with specific tools. So this is like the code navigation, code analysis, code intelligence. So that's very much from like a Visual Studio, Eclipse, etc. IDE perspective. MCP is now this new standard, which is how AI applications are going to interact with each other, both internally and externally. So things like MCP clients, MCP servers. So where it's prompts, tools, data, sampling, etc. So this is a framework standard. So the idea is that all industry players will adopt this framework as a protocol. The protocol then will become established within each of the products and services, and then you can interact with different MCP-enabled services. Google last week announced A2A, so they've got their own protocol as well. So MCP and A2A will interact, but they are different protocols and services. So if we look at how MCP works, this is an example of a standardized development. So the idea is we have an MCP client, so that's our IDE. So in our case, it's going to be Visual Studio Code. We then have data that we have different MPC servers. So in this case, we've got a data MCP server, which allows us to query, fetch data, modify records, handle data streams. So this is an MCP server set up for data. We've got an MCP server set up for our CRM systems that understands everyone in our CRM system. So you can do things like updates, creates, manage, task allocations, etc. And then we've got an MCP server for our GitHub source control or version control. And that allows us to make commits, resolve changes, manage branches, might do things like auto tagging of issues. It might do auto checking of PRs based on code, and then do code updates. And again, all these rely on specific data sources. So what MCP allows us to do is service each of these individual things as a server. So there's some great examples of MCP servers out there at the moment. So Microsoft has released a Playwright server. So if anybody's used Playwright is very much based around web design and patterns and automation and practices. You can now have an MCP server for Playwright for scraping of screen content. So you can ask the MPC server to go and do these tasks. MPC server understands what websites are, what context is, what JSON is, what formatting is, and it can then bring this back. So MCP server is really key to allowing us to do this. So how does this all work? MCP client really looks at how to undertake the actual task. So, how to query the resources, how to use tools, and how to do the responses. And the server is how these features are being exposed. So how does the client consume these features? Train, anything you want to add to this before we go into a demo?
No, I think this is pretty much what we can say. I mean, I would like to show all this in real time in the demo.
Okay, so let's go over to the demo and show this in the demo.
Right. So again, we are circling. I think today we are just circling around AI Toolkit, and in the whole series we have done that. So again, there is a new feature which was not there, I think, before. If you see a previous recording, it was something called as prompt builder. But in the recent, I think, as we mentioned in the earlier part of this session, it's now rebranded to as agent builder, right? So I can do that. I'll come here and I'll just click on a new builder, and you can just get started with it. So now, in the interest of time, I'll just show you two things. How do you import a MCP server, and how do you execute, how do you already use the existing one, right? So there is something called as web developer here in the example. So I'll be using that to showcase and demonstrate what it does. So it has a MCP server already associated with it, and this is my client where I'm currently in. So I'll just click on this web developer, and you can see there's a system prompt, and there is a user prompt and all these things. And you can see it's also running in the parallel, but you can see these are the tools. Lee just mentioned about tools, right? So these are the tools that I've already defined in this one, right? So there are 11 tools. So here, even before I could complete my statement, it has already, it's much in a hurry than me today. So it's already executing and it's generating the code. So what it does basically is it comes up with a website with different sections in it. So I've just given that prompt here, and let's see how it generates that website. It's writing a lot of code. I can see that here, including a placeholder and every other thing. I mean, it's even giving me placeholder.jpg. I have to just replace it with my images, but you can see
Yes,
what it
just
is
while it's
doing.
just producing the page, all we've basically done here is used MCP to create us a website. So we give it a set of instructions saying what we want on the website. The MCP server understands what websites is, has gone away, and actually now starting to build this.
Yes. So these are the instructions that we have given: a fixed bar, a hero section, a featured courses section, an interactive learning paths, a success stories. Right. So let's see if it has actually done it or not. And oh, I also missed a footer with the links of blog and privacy policy and contact us. Let's see how good work has this done. So now fingers crossed. I'm not sure. What do you think, Lee? Will it do the job for us?
Come on, it's the world of agents. It's bound to have done like 98% of the job for us.
Right. And we can see it has done a good job, I would say. This would take at least at least for me, if I have to develop this, I would take at least half an hour to 45 minutes minimum. But you can see everything is in place, right? So with just 5 minutes of one single click, I can see there's post title one. Of course, I have to provide the images and find your learning path. There is some, coloring involved here. CS is also there. Success stories, what are the things, and the best part, can you say this? EduQuest changed my life. I gained valuable things. A testimony that is generated by AI again. Uh, Blog, FAQ, contact us. As I said, a footer should have this. My math, science, language, art section should be there. A get started button should be there. All these things, right? Everything done with a single click. So this is how powerful your MCP is. So what did MCP use in the backend to come up with this? The tools, right? The initial tools I was showcasing here. So these are the 11 tools that MCP has used, right? So edit file, create multiple files, and whatever is here. So now you might ask me, okay, fine, this is great. You have showed me how to use, but how do I get my own MCP server, right? So to do that, let's just click on this, and you can click on add server here on the top. So I'll just click on add server, and you can have multiple things, right? So for now, since Lee also mentioned about Playwright, I'll show you how to import that. So stdio command, I'll be using that one. And here I have the command ready with me. Oh, sorry, I think it changed. Give me a moment. I have my command here. So make sure you have Node installed on your machine before you use it. I can just click on enter and it asks you to create an ID. You can give any ID here. Let me just do it playwright and enter. And it is now searching for tools, right? So it is directly doing that. Let's just give it, yeah. As you can see, Playwright server, you can explore what it does. So it's a very useful server, I would say. If you're working with POC, if you want to try with MCP, start with Playwright because it gives you a lot of amazing features that will definitely wow you. So you can select which tools do you want to add, which tools do you want to skip. But for now, let's say for demo, I'll just click on OK, right? And that's it. My server is ready. You can see earlier there were how many? Around 11 tools, but now you can see Playwright is added here and there are 24 tools that are there. So similarly, I can run it and I can get my output. So Lee, anything to add on to this?
No, so Jard asked a really good question about, when you're building solutions utilizing MCP, what are like the best practices? Should every single agent speak to the MPC server? Should individual agents speak to the MPC server? So, there is really two patterns of approaches. There's what we call the centralized approach, where the MCPs can be connected directly to your orchestrator. So like for Semantic Kernel, for example, and sit in the orchestration layer. And then what happens is Semantic Kernel will manage the MPC connections and expose the other tools, the prompts to all the agents. So what happens is the agent interacts with Semantic Kernel, and then if Semantic Kernel sees it fit, it will allow them to access the MCP functionality. That's great. It really simplifies architecture and ensures a constant way MCP tools can be accessed. But again, going back to what we started off with around security boundaries and permissions, do you want every agent to access the MCP server? It might be a private MCP server, it might be a public MPC server. So you need to think about that. Then you have the strategy of connecting each agent individually to an MPC server. So this is like what we call the distributed approach. So basically, it's where each agent can independently connect. They establish their own connection. So exactly what Shreyan showed, each agent is talking individually. It allows the agents to do their specific task and role. The agent, as we said before, is sort of sandboxed to their knowledge and what they want to do, and you're sandboxing that to the MPC. So it's creating those boundaries again. It does provide a lot more flexibility, but of course it provides a lot more overhead from a developer standpoint, because you've got lots of complex, you've not got lots of complex management, but you've got the management of that overhead on all your agents. So again, best practices, the simple workflows, just use Semantic Kernel as the orchestrator layer and use a centralized approach. The specialized agents, use the distributed single direct approach. It'll be much more efficient. So hopefully that answers the question. I did try and put it in the chat. It might be a bit garbled. But again, I think this is a key thing about MCP. MCP is a new thing. It's 3 weeks. There's thousands of servers out there, and I'll stick in some links to there is GitHub pages with MPC servers available. Microsoft is making massive investments in MCP. We're making Visual Studio Code, AI Toolkit, MCP supported. Again, we're building content and samples around MCP. There is MCP within GitHub Copilot. So if anybody is using GitHub Copilot in Visual Studio Code, there is what we call agent service. An agent service has MCP support. So one of my favorite things now in Visual Studio Code using GitHub Copilot agents is having the GitHub MCP. So there's a GitHub MCP, which is really cool. So you can say it's amazing at helping you refactor your code. So you can say, because it has that ability to go off to GitHub and to look at any content related to what you're trying to build and provide you samples, examples, valid hyperlinks, again, valid hyperlinks back to additional resources. So going back to what Shreyan was saying, is MPC server is it's not going to do all the job. It's going to do 90% of the job. And, and it's that burden of building that scaffolding, what would take you hours, literally, what was it? It wasn't even 3 minutes. It was done in minutes. But then you have to go back as a human in the loop and go, no, I don't want it blue, I want it green, or I don't want this here, I want it there. But it's giving you that immediate scaffolding. Cool. Let's go back to the slides then. So, we're with the closing stages. We have run slightly over, so thank you for staying with us if you've stayed. And I told Shreyan about this. We had too many demos. So takeaways wise, I think we've shown you about how to use and identify agents where they've been successful. Hopefully you'll be able to take agent services to the next level, looking at how you can build with Semantic Kernel, AI agent services, AI Toolkit. Explore the frameworks. That's what we want you to do. We want you to play with the tools, explore the frameworks, use the UI or the code building agents. We showed you both from the AutoGen Studio. Azure AI Services has got a UI as well, but we want you to build an experiment of these. Again, we've got lots of resources. So we've got the dedicated AI Toolkit. If you want to go to the Visual Studio Code Extensions Marketplace, it's literally there. Just go into Extensions in Code, type AI Toolkit. There's lots of docs available. We've got a dedicated channel on Discord for AI Sparks, and we also have a dedicated GitHub repo with all the samples. So everything that Shreyan showed today will also go in there as well. So a couple of questions that people have asked is how to save the chat history to a DB like Cosmos or Postgres. Is that a question, can MCP do that? Or is that a question of how do I do that? Again, if you've got that as a question, Aparna, please stick it in the Discord. Be a bit more specific so I understand the context. But yes, you can in both ways. So you can use an MPC, a database MPC server, or you can use an LLM to do that. Another question from .xv11 is should the MPC server be built in PowerShell or PowerShell IDE? So no, so the MPC server is built in a development language, so like Java, TypeScript, JavaScript, .NET, Python. It's then hosted as a service, so you can either run it locally, it's just basically a set of JSON files and formatting files, or you can host it as a service like using Azure Container App Service. And again, if you want a scalable MCP, you can host it behind something like the Azure API management, so API-M. So that will be an API management platform that Microsoft hosts. You host your MCP behind that, and it will do your load balancing, etc. So you would build it and host it as a service. So it'll either be built locally and run locally on the machine, or built, deployed, and running as a service. I hope that answers that question. Final slide from us is, we hope you've really enjoyed this series. It's been a whirlwind tour of 6 episodes, starting in February, finishing today. Hopefully, if you look back at the content, you can see the massive changes in the products that have happened, the massive changes in technology and models that have been available in a matter of months. We do want your feedback, so please do give us your feedback. If you want to watch any of the episodes, the content's really valuable. A lot of it is fundamentals based. The UIs and screens have changed, but they've only been made better. And again, please do leave us feedback. Again, please join the Discord group. This is where you can continue the discussion. Loads of great discussions here. And again, thank you for staying with us. We have run over, but I hope it's been worthwhile. And a huge thank you to Shreyan. This is not Shreyan's job. He works at KPMG as a developer. He's building this content. He's building these services. He's working with Microsoft in terms of product feedback. And this is what we want from the community. We want communities to be involved with us as the developer advocacy team. And we want you to share your stories and your experiences and how you are using these tools and products in your day-to-day job. Shreyan, any closing words?
No, I mean, I really enjoyed this journey. And again, speaking from the point of AI Toolkit, I would say I experienced an evolution. Like from the day I started working with it until now, I can see the way it is growing. And I'm really excited to see what future holds with AI and agents and everything. So yeah, I mean, it was a great opportunity to share all these things with everyone and showcase some demos. I hope they were enjoyable as well. So yeah, I mean, good experience.
So finally, here's the feedback slide. Tell us the good, the bad, the ugly. We can take it. We want to learn, and we want you to really enjoy these sessions. And again, if you're watching on demand, huge thank you. And again, all the sessions are available on YouTube. There is a series link on the QR code, which was on the first slide. You can get access to that. Again, it's on the registration page for today's session. So again, all those contents are available. And we also have a dedicated channel in the Discord for AI Sparks with links to all that content. So yes, everything will be made available on demand. And there's a playlist. Thank you. And a huge thank you to Rashmita, who's been our awesome producer for today's episode as well. So thank you, everyone. Have a lovely rest of the day, and thank you for joining us.